Hello from Newfoundland. My name is Carol, and I am going to bring you a little lesson plan that I've created. It's a probability lesson for a grade 4 class. I got the beginnings of this idea with this book called Math Misconceptions. I started reading it just before the course started. It's a very good read if you're looking for another math book. Um, this grade 4 probability task is based on the curriculum expectations. The students are going to be doing a probability experiment. They're going to be predicting. They're going to be comparing their results with their prediction, explaining their reasoning. It's all right here. The mathematical processes that they are going to be using are reasoning and proving, because they're going to be looking for relationships. They're going to be inferring and judging and justifying and concluding. They're also going to be reflecting. This is a big piece of this lesson, is they have to reflect and judge the reasonableness and make sense of the math that they see. The Catholic graduate expectations that are embedded into this lesson are being a collaborative contributor. The students will be working in pairs that I chose. Being an effective communicator, they have to communicate with each other, with myself, with the whole class, and a reflective, creative, and holistic thinker. The learning goals directly link back to the ministry document, the expectations from the ministry document. They are, I can conduct a probability experiment, I can use reasoning to determine if the game's fair, and the last one, actually, the last learning goal is right from the Van de Waal text. It is what he talks about, the law of large numbers, where I want the students to be able to see the large sample and see how when you get a larger sample size, you will get closer to the true probability, that the real probability will reveal itself the larger sample size that you have. So that's my third learning goal. Big ideas are that probability is a measure of likelihood. The Van de Waal piece again, the law of large numbers, that data is a lot better if the sample size is big. And the other one is actually a big idea from number sense, that numbers are connected to each other. And I think that the kids will see that. So the materials that we are going to use, I have all of these in my class. I suspect that you do too. We play a lot of games in my class. I think it's a great way to learn math. We play at least once a week, often twice. Really motivating for the kids. I have just normal, regular dice here. I also kicked it up a notch for some kids who are good with multiplication or want a bit of a challenge. So I'd have some 10-sided and some 12-sided dice available too. I have a baskets for rolling the dice in. I find that it's just a management technique. I just find that if they're rolling the dice into a basket, they're not diving under the table to get a dice. The lined paper, I specifically said lined because they're going to want to organize their data. They're going to want to look at it closely. Pencils, multiplication charts. If they have an IEP, for sure I'd let them have a multiplication chart if it's on their IEP. If not, I'm going to hold those multiplication charts until they finish the experiment. Then, for sure, if they want to use it, if they want to look at that multiplication chart to see a pattern, absolutely, I would encourage that. But I want them to do some multiplication on their own before that. Math journals, we're going to write about what we learned at the end. The Minds On activity, I own this book, A Very Improbable Story. I would probably read it to the kids, But I don't know if you own it, so I put a little link to a YouTube video here. It's a cute little story where these two characters play a few games of chance, and they have to, the whole point of the story is determining whether or not the game is fair. And so when we're finished it, I would get the kids to turn and talk to their elbow partners, talk about the games, that the 4 games that these two characters played. I'd have these 4 games posted somewhere, have them talk about specifically, were these games fair? And we would talk about it as a whole class for a bit, not too long. Then we'd get on with the task. So like I said, they're going to work with partners. I'm going to have chosen the partner, and they are going to decide whether or not a game is fair. And I want them to make a prediction about this before they even put their hand on a dice. I want them to really think, is this going to be fair? So the game is that 2 dice are tossed, and if when you multiply the 2 dice together, the product is even, then player 1 gets a point, and I want player 1 to write the equation down as well. If the 2 dice are tossed and the product is odd, then player 2 gets a point, and player 2 will write that equation down. So I want to know who they think is going to win, not who they think is going to win. I want to know, do they think the game is fair? Yes or no? I just want them to write yes or no on a sticky. They don't have to write their name. They don't have to write anything, just yes or no. I think I'll have them maybe bring the sticky note up to me or put it on the board under either yes or no. And I would give them the basket with, and they could pick a couple of die and get some paper and some pencils. I might, I mean, I'm hoping I don't have to do this, but I might ask someone to define odd and even for the class, and I might ask a student to say what a product is, but I don't know, it would depend on the class. So my expectation is that these kids are going to say, yeah, it's a fair game. I think they're going to say it's a fair game because they believe that when you toss dice, that's what makes it fair. So I'll see, but I'm predicting, my prediction is they're all going to say, yes, it's fair. So when we move to working on it, they're going to be with their pairs, and they can each have 1 die, and they both roll the die into the basket, and then they look at the 2 die and they multiply them together. And if the product is even, player 1's going to give themselves a point, and they're going to write down what the equation is. And if the roll is something like 3 times 3, 2 3 show up on the number cubes, then player 2 is going to write 3 times 3 equals 9, and they're going to give themselves a point. So, and they're going to do this for 25 tosses. So as they're working on this, I'm going to be circulating through the classroom, and I'm going to be asking some questions. Now, I used the document, the building capacity document called Asking Effective Questions, to pull some questions, some probing questions. I want questions that are going to push the students thinking forward. So I'm going to be asking them what they notice, what results are they getting, are they wondering anything about the results? So I think that after the students start recording their results, they might start to think that the game's not fair. They might see that even is more likely to win. But I honestly think that they're just going to say, oh, well, it's because I have bad luck. I don't think they're going to know that even is going to win for sure, because when you multiply an even and an even number together, you're going to get an even number. And when you multiply an odd and an even number together, you're going to get an even number. Because multiplication is just repeated addition. And so when you multiply an odd number, you're just adding it by an even number, by an even amount of times. So I don't know if they're going to see that or not. Anyway, I'm going to be asking them questions, asking what they're wondering, maybe if they're having some trouble, maybe advising them to put it in a chart. I'm not going to tell them how to put it in a chart, just advising them maybe that makes it easier to look at. I'm going to ask them, is it reasonable to believe that the game is fair? Like if even is so far ahead of odd, I still think that even though the game is not fair, I honestly think they're going to say, nope, I'm just having bad luck. I don't know why I'm not winning. Wow. It'll be interesting to see. I have not done this with the class, so I don't know. I honestly think, though, it's going to be the third part of that learning goal, that Van de Waal piece, that looking at the large sample size, that's going to be the part where the kids go, oh, yeah, look, only even one. None of the odds won. Come on, there's got to be something. This game is rigged. They're going to say something like that. If I have anybody who is finished early, I would just get them to get two different dice, like maybe a 6-sided one and a 10-sided one, something like that, and ask them if their results are the same. So when we come back together to consolidate, I would ask all the player ones to raise their hand. Ask them to keep their hands up if they won. I'd get some kid to go up and tally that on the board under the word player one. I'd ask all the player twos to raise their hand. I'd ask them to keep their hand up if they had won. I'm not expecting to see any player two hands. I think that is when the big aha moment's going to come. I think they're going to say, what? Wait a minute. Why didn't any player twos win? And I think that's when we can talk about how powerful that large sample size is, that law of large numbers. I think that's when you're going to say, wow, all this data should be telling you something, guys. What's it telling you? Now, I'm hoping by this point, a student or a few students will have figured it out. They will have said, wow, even's definitely going to win because you're a lot more likely to get an even number than you are to get an odd number. But if they haven't figured that out yet, I will keep trying to push them along. I am going to remind them of what they wrote on the Post-it note and ask if anybody wants to change their prediction. I'm sure there's going to be a lot. And they're going to have to tell me why they're changing their prediction. I'm hoping that a student will be able to explain to the other students why the even is definitely going to win. If I still don't have a student that's ready to do that, I'm going to push their learning a little more by asking them. I would probably write or get a kid to write 3 different headings on the whiteboard. They could write both even, mixed, or both odd, maybe something that looks like this. And I would get students to come up one at a time to write down some of one or two of the equations that they had. And I'm hoping that I will be asking them to look for patterns and look to see what they notice. I'm hoping that they will see that in the both even and the mixed columns, the answers are always even. and that the both odd is the only one that has odd numbers. So then that would be when I would address this misconception that the game is fair. It's a misconception to think that the game is fair because we're using dice. The game is definitely not fair. It's not fair. It's not fair. And I'm hoping they'll see that. And I think I'll talk about the assumption of why we think just because it's with dice that it's fair, and that how that can be really misleading. And I think, I don't know if I'd have time, but I might talk about other assumptions with gambling that people make. After, I'd have the students writing in their math journal. This would be assessment as learning for them to reflect back on what they learned. So I would have these questions written on chart paper or on the smartboard. What stuck with you today? What did you learn about the relationships between numbers? I'm really hoping that something will have whetted their appetite to learn more about that. Why did you make the assumption that the game was fair? And then this one is really going to push their thinking. Could you have figured out that this game was not fair without having to play the game based on theoretical probability only? We wouldn't have talked about theoretical probability yet, so it would depend on time if I would do this, but and theoretical probability, I don't think it's in the grade 4 curriculum, but I think some kids might want to think about, hey, could I figure this out without actually having to play the game? I don't know if I'd use the word theoretical. I'll have to think about it. It would depend on the class. My targeted intervention, if I notice that some students haven't made a meaningful connection, I would get them to actually fill in the chart themselves of what the one that we did together. I'd have them do it themselves and keep rolling and filling in. Assessment for learning, what I'm going to look back on and see if my kids are ready to dig a little deeper, and if they understood some of what we did today. I would ask them if the game would be fair if we had added the 2 days together instead of multiplying them. And I'd ask them to explain that. And if they want to give me a list of all the different combinations, that's okay with me. If they want to tell me some other way, that's okay. I just want to know, do they understand that they can't make the assumption that it's going to be a fair game just because there's 2 dice, and that there's ways to figure out whether or not a game is fair. What I have learned that people often take information at face value and don't consider all the factors that are taking place during a game of chance. I'm going to say adults do that too, but kids for sure do that. And I really think that kids are still finding out about numbers and the relationships. I think if you ask this to an older class, they would know right away that when you multiply an even and an odd together, that you're going to get an even number. But grade 4, they're still learning about that, and that's great. They need lots of opportunity to tinker with numbers, to play with numbers. Where would I go next? I would have the kids do some coding. I think coding and probability are marriage made in heaven. I think it's great. I'd have them code and make a new game, a game where if the 2 number cubes were rolled and the product was less than 12, then player 1 would get the point, and if the product was 12 or greater, player 2 would get the point. And we'd only use a number cube from 1 to 6. I don't know if I'd let them do this theoretic or experimentally first. I would ask them if they could figure it out on paper first. Could they figure that out theoretically? And then make a scratch game out of it or a microbit game out of it. And if they want to play it, great. And I wonder if they think that's going to be fair. I think they will figure it out, and it's very close to being fair, but it's not. 12 or greater is going to have a better chance of winning. So at our school board, we have our learning plans have to include some kind of deep learning element and global competency. So I included pedagogical practices when I used questioning that was revealing the students' thinking. And the learning environment was also a deep learning environment because it was student-centered learning, it was interactive learning, and the global competencies of critical thinking and collaboration were highlighted in this lesson plan. I hope you enjoyed this lesson. I hope you use it someday, and it was great getting to know all of you.